When you have to put a number into scientific notation, you've got a couple of things you've got to be considering. Suppose we tell you we have a very large number, like the mass of the Earth. This number is big. Let's show you how big it is. To one significant figure, here's what we've got. That's the number. To one significant figure, this is the mass of planet Earth. It is 6 followed by 8 groups of 3 zeros, kilograms. That's 24 zeros. Now, these zeros, they're placeholders, and that's all they are. They just tell you how big the 6 is. Now, what would be nice is if we could stop writing so much down, so many zeros. So we're going to put in scientific notation. It's understood that the decimal point is right here. Now we want to move the decimal point so that there's one non-zero number to the left of it. So we're going to move the decimal point all the way to here. And we're going to count how many places over we go. Now we moved the decimal point when we did this. We moved the decimal point to the left. And we count how many spaces we moved. And we moved basically to the left 24 places. Now when you move the decimal point to the left, when we put it into scientific notation, we're going to get, this is going to be 6 times 10 to the 24th kilograms. So when you have a very large number, okay, you move the decimal point to the left, and the power of 10 is positive, and it goes up, however you want to say it, the number of places that you move the decimal point to the left. So that's the basic rule. When you have a large number, this is what you do. Move the decimal point to the left, raise the power of 10 the number of places that you move it. For example, if you have 47 million kilograms, what are we going to do? Well, we're going to move it all the way to the left, so there's only one non-zero digit in front of it, right to there. We're going to count, and then you're going to have 4.7, and you move it 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th kilogram. So again, if it's a large number, decimal point gets moved to the left, the power of 10 is positive, and you raise it. How many places you move to the left. Simple. Let's take something very small next. Let's take a look at something on the other end of the spectrum. Let's look at the mass. Move this back down so you can see it. Let's look at the mass of an electron. It's a small particle. It's not very massive. So here's what we've got. We've got 0, point. I'll do this in groups of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 6, 7, 3, 6, 9, 12, 15, 18, 21, 24, 27, and you have 911 kilograms. That's the mass of an electron to 3 significant figures. Now note that these are all left-hand zeros, and they are just placeholders. They tell you where the sig figs start, how small this number gets. Now, when you move, now we're going to move the decimal point to the right, so that there's one non-zero number in front of it, right there. We're going to count how many places we moved it. 3, 6, 9, 12, 15, 18, 21, 24, 27, 29, 30. I think that's what we did. 3, 6, 9, 12, 15, 18, 21, 24, 27, 28, 29, 30. We moved it 31 places. So we moved it to the right, and we moved it a total of 31 places. That's 10 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 plus 1. Yeah, 10 times 3 is 30, plus 1 is 31. And now what we've got here then is the number is 9.11 times 10 to the negative 31 kilograms. Now, this was a small number. Okay, now when you have a small number, you move the decimal point to the right, and the power of 10 will be negative, and that means it goes down the number of places that you moved to the right. So that's how I remember how to do this. If it's a small number, the decimal point moves to the right, so there's one non-zero digit in front of it. The power of 10 is negative, it goes down. For example, another one. Suppose we have 0.006723 kilograms. And we're going to move the decimal place. This time we're going to move it so we have one non-zero digit in front of it. So we moved it 3 to the right. So in scientific notation, this number would be 6.723 times 10 to the minus third kilograms. So that's the deal. That's how you do it. So let's try a couple of examples on your sheet. This would be page 4 in your packet, expressing very large and very small numbers. And again, the way this works, if the number is small, if it's very small, we move the decimal point to the right, and the power of 10 is negative, and it goes down. If we move the decimal, if we have a very large number, we move the decimal point to the left. The power of 10 will be positive, and it will go up the number of places that we moved. So very large, move to the left, power of 10 goes up. Very small, move to the right, the power of 10 goes down. Let's try a few examples. First one, we have 3.25. Move the decimal place 2 places to the left. That means it's going to be 3.25 times 10 to the positive 2, or 10 to the second. Number 21, we've got 0.361. We're going to move it 1 place to the right, so it's going to be 3.61 times 10 to the minus 1. Let's try a couple more. Now, there's something we haven't talked about yet, and that's significant figures. When you do scientific notation these days in physics, you have to include the sig figs when you make the transfer into scientific notation. So if we look at a problem like number 11, jump to 11, everybody. Notice that it's 240.000. That's 6 significant figures. You got to keep them when you make the change. We're going to move it 2 places to the left. It's going to give us 2.4, and then we've got, let's think about it, we've got times 10 to the second, but we've got to keep all 6 significant figures, so you've got to keep the 4 zeros. You've got to do that. Let's try one more. If we go across to number 31, well, actually let's jump down to number 33. Number 33, everybody, we're going to move it 1 decimal point to the right. We're going to get 7.514, and it's going to be times 10 to the minus 1. However, these are final zeros after the decimal point. They're significant. You got to keep them all, so those 4 zeros are held on to. So what's the deal with scientific notation? You've got to hold on to the sig figs in addition to knowing how to do it. I would like you to try the rest of this page.